Thank you everyone for joining us on IMarEST TV today for this webinar prepared by our Human Element Special Interest Group. And without further ado, I will hand over to our host for today, Will.
Thanks very much, Katrina. Good morning, everyone, and welcome to the Human Element Working Group hosted webinar about the SAFEMODE Research Project that focuses on the synergies between the air and the maritime sectors from a human factors perspective. This webinar lasts for about an hour and consists of a 45-minute presentation from the SAFEMODE Project, followed by questions proposed by yourselves on Slido, as Katrina's just mentioned. Remember, this webinar will also be available on IMarEST TV in due course. My name is Will Tutton. I'm your host for this webinar as a member of the IMarEST Human Element Working Group. For those who don't know me, I'm a specialist human factors inspector at the UK Marine Accident Investigation Branch. I'm a Chartered Fellow of the Chartered Institute of Economics and Human Factors and an advisory board member of the SAFEMODE Project. In the marine sector, we're very familiar with the term human element, defined by the IMO as the full spectrum of human activities undertaken in the maritime sector. In this webinar, the SAFEMODE Project leads will explore how we can learn from looking at SAFEMODE activities from the perspective of human factors and ergonomics that encompasses organisational aspects as a part of our thinking about safety improvement. So there are two key themes in this presentation, and those are the importance of effective investigations and the effect just cultures can have on safe performance. Today, you'll be hearing from some highly regarded experts on this important subject. The first part of the presentation, you will hear from Dr. Simone Pozzi and Dr. Maria Carrera, who will introduce the project, its aims, and the organisations involved. Dr. Pozzi is the CEO of Deep Blue SRL, the project coordinator, and has 20 years experience of working in a variety of safety critical sectors. He also lectures at a number of European industrial organisations and universities. Dr. Carrera is a researcher from the World Maritime University, has a background in clinical industrial psychology and previously worked at the Lloyd's Register and the Schumacher Institute in maritime human systems roles. The second part of the presentation will be led by Professor Osman Turan from Strathclyde University, who will provide an overview of the technical approach to the project and its development. Professor Turan is one of the world's leading experts on shipping safety and has been at the forefront of over 20 maritime safety research programs. In the third part, Dr. Rafet Kurtz, Associate Professor at the University of Strathclyde, will introduce the Human Factors Taxonomy Shield that's been developed to support learning through the SAFEMODE project. Dr. Kurtz is a well-known expert on the application of human factors engineering principles to maritime systems research. The fourth part of the webinar will cover the case studies used in the SAFEMODE research and is presented by Dr. Jialun Liu, Associate Professor at Wuhan University of Technology. Dr. Liu specializes in transportation systems, in particular smart shipping and autonomous control and testing of ships. The fifth and final part of the webinar, you'll hear from Dr. Barry Cohen from Eurocontrol, who will present the findings of a study of just culture in the maritime sector. Dr. Cohen is a highly respected human factors practitioner within the field of human reliability and latterly led the European Safety Culture Programme for over a decade, working across 30 different nations. So with no further ado, Simone and Maria, over to you to begin the presentation.
Thank you, Will. So thank you for having us here. And we will start with this brief overview of the project, telling just a few high-level information about what is SAFEMODE and our main challenges ahead of us. The first important point about SAFEMODE, we will come back to it quite a few times, is that it's a project trying to find synergies between maritime and aviation for human factors and safety. The project is a large project. We have a consortium of 34 partners, including some of the organizations present here today. I represent Deep Blue, the coordinator. Then we have University of Strathclyde and Eurocontrol, the two scientific coordinators. We have the World Maritime University. And we also have as part of the international partners from Russia, China, Indonesia, and Philippines, University of Wuhan, that it is with us today. I quickly scrolled through the end users, but I want to come back to this one. As part of the consortium, since we want to have an impact on the design part and on the way the operations are being done, we also have manufacturers, ship and airplanes, and operators in our consortium. The topic that we are addressing in SAFEMODE from the Commission asked us to do three main things. The first part is relates to data. So we have to compile and analyze a large quantity of real-world data, safety data, so near misses, incidents, and accidents. Then we have to develop methodologies to improve the human factors methodologies to analyze the safety data in order to feed design of systems and safety assessment of operations. The third major aspect of the project is the one that I anticipated before, is the cross-fertilization between waterborne and air transport. The challenge in front of us, when we started the project, when we started actually writing the project, we could clearly see the challenge in front of us. When it comes to human factors aspects in safety events, the major challenge is that typically what you see is the tip of the iceberg. It's what is easy to see, what happened. So who did what, but not the why. But what is interesting for human factors aspect is what is really below the surface. So the human performance aspects, so the fatigue, workflow, situational awareness, the interaction with the human-machine interface. Work is done, the practice as it is done there, and also the cultural aspects, including safety culture, human factors, maturity, and organizational culture, national culture. So in our project, we are trying to deliver an impact by digging deeper and going below the surface, by improving the quality of safety data we collect, by deciding, understanding what we need, what we would need, and trying to have an impact on the policies to improve the data collection, to fine-tune, to capitalize on years of human factors research and decide which are the best-in-class, state-of-the-art methods to improve the human factors analysis of safety data. And then that's the trickiest part, how to feed all of that information back into design and into operations. So to close the loop, so to speak, so that we habilitate effective learning from the safety data collection to the design and to the operations. So I give the floor now to my colleague, Maria.
Thank you. Hi, everyone. This is Maria, Research Associate at the World Maritime University. SAFEMODE Project is also delivering impact through the institutionalization strategy we are implementing with the aim to first support regulatory developments and second, facilitate industry uptake of SAFEMODE developments. The project earlier on conducted a stakeholder analysis in order to identify and prioritize the primary stakeholders who have influence and affect decision-making regarding human factors in the industry. So we are engaging with all these primary stakeholders at different levels. First at the public sector level, so including flag states, IGOs, in fact, MCA, EMSA are part of our advisory board. We are also engaging with trade-oriented organizations and NGOs, and also civil society-oriented NGOs, such as professional bodies like IMarEST. So next slide, please. The involvement strategy with the stakeholders we have in place is composed of three stages. The first one has been already completed, and we have conducted consultations, meetings with representatives of the primary stakeholders I explained earlier. And in order to share the project, to share the avenues we are exploring, to get their input and feedback about SAFEMODE developments, about the expectations about our developments. Now we are moving on to the next stage, this webinar is part of it, and we are also organizing workshops with primary stakeholders and advisory members of the advisory board about this SAFEMODE development. So now my colleagues will explain in more detail these developments. So I will over to Emek.
Good morning, everyone, and thanks, Maria, for passing the floor to me. I'm going to present today SAFEMODE Project's Human Risk Informed Design Framework. First, I want to start with showing the overall structure of SAFEMODE. If we divide SAFEMODE structure into two parts, on the left-hand side, you will see technical and research work. And in this technical side, we are developing human elements taxonomy, which enhances the quality of human factors data collected from accidents and incidents. By using this taxonomy, we are also developing a human factor database, which will create necessary human factors data. We are also developing in this technical side a human assurance toolkit, which hosts tools and techniques for designers. Finally, we are developing risk models, which will help quantification of safety improvements. HURID takes all these technical outputs and makes customizations and delivers them to our maritime and aviation case studies. So HURID plays an important role to making that important transition, taking research outputs and making them practically available for our case studies. In order to achieve this important role, HURID needs to support human factor related safety learning in following key areas. First, HURID needs to facilitate data capture, which will include recording of accidents and incidents together with sufficient human factor details and contextual conditions. Then HURID facilitates conducting data analysis, determine causes and contributions, as well as assesses repeating patterns and scenarios in safety occurrences. This enables us to achieve better safety learning, which can be widely distributed across the industry. One of the key contributions of HURID is risk-informed design, in which designers and safety professionals are able to make risk-informed decisions on aspects like interface and tool design, as well as design of procedures and tasks. Finally, HURID enables operations to be monitored continuously without waiting for an accident outcomes by focusing on performance variations in various operational states. Another aspect that we considered when developing HURID framework is to address the needs of different end users. In order to achieve this, we identified potential use cases and associated user requirements. As part of this activity, user needs have been explored based on constant interaction with end users, for example, from manufacturers, service providers, operators, etc. As a result, 6 main categories of HURID end users were identified, which includes HF practitioners, designers and developers, safety experts, inspectors, surveyors, auditors, investigators, and human factor novices, all of which possesses different levels of human factors expertise, which we will need to address. Having identified the use cases, the next challenge is to define how each user will utilize these tools and approaches. This is why we are creating the HURID framework to help this process and ensure stakeholder take-up. HURID is a multi-step process, as part of which we first understand the design intent, then identify human impacts, then select and apply HURID approaches and techniques, and consolidate design requirements. Therefore, HURID helps the designer to navigate through the various human factor approaches and techniques to see which ones are best suited for the design. Considering the current lack of human factors expertise in maritime sector, we think that there is a need to support end users when selecting and applying HURID approaches and techniques to their specific case studies. Understandably, not all techniques can be applied at all life cycle phases. HURID takes this into account and guides users to identify correct tools for their case study, which is under investigation. Figure on the left provides typical life cycle phases when considering design, starting from concept stage to all the way to operations. Also, each technique or approach will need different levels of expertise. The table on the right here shows the techniques from human factors toolkit and the principal human factor impact areas they serve for. On the y-axis here, approximate grading according to the need for human factors expertise is given, while x-axis here, we can see different application areas. We have also categorized tools and techniques based on their purpose so that we can easily filter them to match the case study needs. Currently, we have over 19 methods, which have been further divided into 7 clusters, which are namely HMI prototyping tools, tools for HF guidance, task analysis tools, human reliability assessment methods, identification of user needs and requirements, organizational systematic analysis, and real-time simulation tools, which also for different needs. We also believe that it is important to make HURID accessible for maritime community, therefore developed human risk-informed design framework and the selected tools will be available on a web-based platform called EUnit. Through EUnit, we are aiming to reach wide range of stakeholders and increase the impact of our project. One of the key issues in maritime sector is the fact that human factors expertise is new and rare. Necessary resources and fundamental information are not available easily for stakeholders to access. Therefore, Seabrary is specifically designed to address this specific gap. A successful example is already available in aviation sector, which is called Skybrary. We are cooperating with Skybrary developers in SAFEMODE project, and by utilizing the lessons learned, we are transferring the concept to maritime. This will be one of the legacies of SAFEMODE project, which will be hopefully become the main safety learning reference point for human factors in maritime domain, even after the project completion. In order to test the HURID concept, we selected one of our previous research outputs to see if HURID can help development of this conceptual design on integrated decision support system for collision avoidance on ships. Concept of the system is shown on the left-hand side here. Details of the concept is not important for this presentation, but in brief, we wanted to test a better way of presenting information to officer of the watch with an intention to improve collision avoidance. Through the application of HURID framework and its techniques, in this demo case, we showed that we are able to guide designers to systematically go through their concept and ensure human factors considerations are addressed at the core of each stage. In this way, we can design systems which are fit for operation. Hence, we can achieve human-oriented design and operations in maritime sector. So if you look at the example, I'm not going to go through all of it, but we applied task analysis to define how the officer of the watch interacts with the system and then design capabilities according to those limitations or according to those tasks. In HURID, we also want to facilitate the quantification of safety improvement achieved through a new design. For this purpose, SAFEMODE developed human-centered risk models focusing on key maritime accidents such as groundings and collisions. This means that the new system introduced in the previous slide can be included in our models as a new barrier in our collision model, for example, and overall safety improvement can be calculated against the benchmark case. So you will see that in our collision models, we have various barriers and the detailed modeling is done in separately. Once completed, HURID will be validated through real case studies. One of these case studies will be presented today by our colleague from Wuhan University of Technology on operator assessment of remote control ships. So I will finish my presentation by saying that, and thank you for listening. Now I pass the floor to my colleague Osman Turan, who will present how Shield database will enable us conducting these analyses. Thank you very much.
Thank you very much, Emek. Good morning. Following on from my friend's presentation, taxonomy and the database provide a fundamental step towards achieving the SAFEMODE aims and objectives. Within that, we try to set up a easy, consistent, but transferable framework so that we are able to really capture the safety occurrence reporting and analysis systems, SORAS, in a systematic but also easy to understand way. SAFEMODE focus encompasses the it encompasses the, all the systems that have been put in place at industrial, research, or institutional level to improve the safety after an accident. And that's where a suitable taxonomy is fundamental to achieve these, the objectives. For this reason, SAFEMODE started the development of human factors taxonomy from the generic SORAS definition. When we select the SORAS from different safety critical domains, two main criteria were considered for inclusion in the analysis. First, in order to include in the SORAS, we need to look at the SORAS that addresses the role played by human in contributing accidents, and also including the the SORAS that have been used by industry at operational level or formally adopted by official regulatory or policy-making bodies. Within that framework, we have searched aviation, maritime, railway, nuclear, and even the space operations to capture the the SORAS and the taxonomies that have been utilized so that we are able to scan and screen and analyze the details to capture the most suitable systems to bring into SAFEMODE. For instance, MCHIP by EMSA has been looked at, and as mentioned my colleagues, EMSA has been in the advisory board and has been engaged in the providing a constant feedback. Within that, we looked at the requirements, and these requirements are providing us to make sure that we have the level of granularity where we minimize the the sufficiently generic that minimize the risk of inconsistent interpretations, but also sufficiently detailed to allow for understanding of the human performance and the contributing to the accidents, and is sufficiently detailed to allow for understanding of the role played by the organizational and contributing factors. Also, it is linked to the human factor concept to make sure that we are looking into state-of-the-art human factors models and assume an adequate human factor competency within the system that we selected. Also, we need to emphasize that we try to minimize the risk of blaming the individual. This has been the sore point in the maritime, especially highlighted by many stakeholders. Linking with the application domain, we want to make sure that transversal terms are utilized. It is applicable to both the aviation and maritime, as well as the other domains. And also we use the the specific terms when needed to understand the role of organizational and contextual factors that contribute to an unsafe human performance. Within these requirements, the SHIELD human factors taxonomy has been selected by comparison the taxonomies and the gap analysis. We look at the epidemiological versus model-based taxonomies, and also the identification of the transversal or domain-specific taxonomies. As you can see, epidemiological and domain-specific taxonomies are dominating the system, and we looked at all of them, applications, limitations, and also transferability. And we decided, as after this, the detailed investigation and screening, we selected model-based taxonomy, for easiness and transferability, together with the domain, the transfers that can be, applied. Within that, what we have looked at based on the conditions and the screening, we shortlisted 5 taxonomies: Tracer, HERA, NASA, HVAX, and HASTE. The shortlisted, it's possible promising to provide us what we need. And we have also looked at the further, the selection process to make sure that taxonomy is suitable to adequately account for higher level organizational issues and has a common bridge at the level of the individual performance. Based on that, we looked at the HERA and NASA human factors to combine to generate the SAFEMODE Shield Human Factors taxonomy. This would, would capture the occurrence facts, then occurrence assessment in terms of categories and severity, but also capturing the human factors aspects like organizational issues, supervisory issues, preconditions, and the individual acts that contributing to the incidents or accidents. But also we don't stop here. We look at the safety positive actions and learning, so that we can look at the near misses or the incidents that to capture the positive barriers that has been successful to prevent accidents or mitigating the consequences, and also provide a safety learning. This is essential for us to build the and capture the necessary information and translate into the HURID framework to generate the the human centered design process, which includes design as well as the operation. Within that, when we look at the SHIELD taxonomy, we look at the organization as a top level that covers the culture, climate, processes, and resources. Then next is the supervisory aspects like failure to correct known problem, inadequate supervision, or supervisory violations. And preconditions that they generate the environmental factors such as the communication, physical environment, self-imposed stress, or technical environment that sometimes we think that the design is perfect, but we know that it is not. It is addressed, these weaknesses are covered by the humans' better performances. This needs to be captured as well. Individual factors like the awareness, cognitive factors, adverse physiological or psychological elements, or mental aspects, competence and skills, as well as the perception. And the last element is the acts that providing us the perceptions, individual, planning and decision making, memory, response, executions, and intentional deviation from the authorized procedure. This provides us the key, the framework to build our taxonomy, and also the database that essential for achieving the aim and objective. Within that, currently we are accessing the maritime data sources and the accident investigation reports around the world, which are publicly available as a very rich source for us to start the utilizing the accident investigation reports to build our database, but also implement our accident, the analysis, or taxonomy. Within that, we are also looking at the, currently we are focusing on UK, MAIB, EMSA, Australia, Denmark, Sweden, US, Canada, but we will expand it to others that available, which is we are grateful. But also we are focused on collision, grounding, and contact, but this will be expanded to later the other areas that could be onboard incidents and accidents, occupational, or the fire, etc. We also try to capture the company accident incident reports to generate our the databases for the safety learning. Within that, if you look at the example what we do, we take an accident report, for instance, the MAIB's accident report, a group of people with the covering different expertise like seafarers, human factors experts, and we go through the report and as a workshops go step by step and identify the acts, like the individual acts that create the accident, then the preconditions like a mental fatigue with a taxonomy and codes, and also limited experience like the supervisory elements and the organizational aspects like the personnel, availability of personnel. Within that, we create a database that consistent and also utilizing the standard taxonomy, which will give us a significant resources to build our HURID framework for design and operation implementations. Human taxonomy is providing us the the two-way connection with the risk models that my colleague had presented. First is the data collection that utilized for both taxonomy and the risk models, and second is the analysis of the influence layers. These are the feeding into the the risk models and the design the framework. Additionally, human shield taxonomy would be used for the analysis of near misses, especially for the shipping companies which are collecting this type of near misses. And if they use a standardized taxonomy, it will provide a significant, very rich resources to enhance the safety. Another aspect is the occupational incidents, like enclosed space entry, which is one of the sore aspects of the the maritime sector, and this are the good examples that where we are trying to head to. With the current status, we completed the Shields human factor taxonomy with the stakeholders' continuous feedback, which these stakeholders include EMSA, national authorities, accident investigators, and shipping companies, to make sure that we have we have the right the input, and this is based on the realities of the industry, because as it is mentioned, this will be the aim to be utilized by the industry. Second aspect is that currently we are utilizing this taxonomy to and apply to set of aviation and maritime accidents to build a database, but also learn. Second, the future steps is we will be organizing a stakeholders workshop to test and refine the taxonomy and make it available for pilot application by stakeholders. And the database will be complete and maintained after project, and this shield file taxonomy will be available towards the for the stakeholders that they can utilize this for the after project completed for the industrial applications. And this data will be anonymized, and we also invite people from industry to support the database creations as well. With this, I would like to thank you for your attention, and we will answer the questions together. Thank you. I'll pass over to my colleague Jalen. Thank you.
Hello, everyone. So I'm Dr. Jalen Liu from Wuhan University of Technology, and it's a great honor to be here to tell you something about our case study for the maritime forward-looking. And what I'm going to tell you is about something about the operator assessment of remote controlled ships. The total goal for our case study is to use and validate the HURID tool to help a proper design of the HMI. So why do we care for this kind of remote control? Because nowadays we are kind of embracing the rise of intelligent ships. Since 2012, worldwide, university, companies, institutes have been working on developing such kind of commercialized civil ships for the future. And companies like Rolls-Royce have already put forward this kind of remote controlled concept. What we think is that remote control ships are quite appealing because it's a good trend point between current conventional manned ships and for the future totally unmanned ships, which means the remote control ships means, well, the captains are sitting on shore instead of sailing out with the ship. Well, for our case study, the description is quite straightforward. First of all, we will initialize kind of HMI design to be our first case. And we use this HMI with a scenario record from live traffic in Zhoushan or in Nanjing, somewhere in China for the ferry boats. And we can also provide some feedbacks, the real data from remotely controlled model skilled ships to image that the ship is kind of is something similar to conventional large skilled ships. So we have the scenarios, we have the ships, and then we merge them together for remote control operators like our student here. So he can, she, or can use our system remotely control model ships, avoiding some other ships in this kind of record live traffic. We can also use a simulated model ship to represent the remotely controlled ships. So throughout the study, the captain or the remote control operator will wear an EEG device. So with the EEG device, we can measure the brain waves of the remote operators, and we can we can set up some scenarios like failure of subsystems. We can test some grounding avoidance, collision avoidance. During this kind of operations, the brain waves will be changed. So we have different data from the EEG, and we can also record the fatigue mistakes performed by the remote control operators with our initial design, HMI design. But afterward, we will use a tool of HURID to redesign the HMI to help the captain have a better feeling and better performance during this kind of remote control operations. So we can have a full loop for the validation of the HURID. So in short, our case study will try to gain some insight into the possibility for safe human operations of remotely controlled ships. The exercises we've conducted to explore the possibilities, limits, and safety margins of remote operations. What we are going to provide is such a tool with record scenarios and remotely controlled ships to merge them together for the captains with different HMI, either designed with HURID or without HURID, and all the data will be recorded with EEG. So that's pretty a simple description of a case study. We have a lot of settings for the case study. First of all, we have some assumptions. We assume that the human on board for the future for case study are only for maintenance. So they are primarily engineers. The functions related to navigations, such as the captains, are performed by humans on shore through a remote control platform, which are, as shown in the previous slides. We assume the remote control modes have different options. Well, the captain, the remote control operators on shore can remotely control the ship by directly control, which means they give the orders of the propeller or the rudders, or they can indirectly control the ship. They can set the expected course and the speed, which in that case, the ship will run in a half human, half machine mode. So we have to limit our research scopes. So in our case study, the HMI here, we refer to the one that the remote operators use to control the ship, including the visualization of the environment, including the information and alerts provided to the operators. But we do not consider the design of the remote control center. The target of human factors in our case study is the mental working load, which may lead to the human errors. And we quantify the mental workload by EEG signals, the brain waves. We will perform two groups of tests. One is without the HMI design with the support of HURID, which is primarily designed by us. The second control group will use the HMI with the support of HURID so that we can validate the usage of HURID. We will collect some direct and indirect data. The direct data will be the operator brain waves, where the EEG. And then the indirect data will be the experience of the remote control operators with different HMIs. We will perform some interviews, get some feedbacks and answers and questions from the operators. How can we evaluate the usage of HURID? We have two sets of questions. First of all, does the design considering HURID help remote control operators? And hopefully we can get the answer yes. With the support of HURID, we have a better HMI, we minimize the working load, we help the operators. The second set of questions will be something like, what do we need to consider in the design of HMI for remote control operations? That will be something we give back to the development of HURID. We would like to have kind of a guideline or improvements to the current HMI design. Throughout our exercises, the remote control operators will perform some collision avoidance with the live traffic record in Zhoushan. Zhoushan is somewhere in Shanghai, for there are some ferry boats. We have throughout the feedback, we have the feedbacks from the model ships. We provided the information from the real model ships so that we can have delay and decay due to the internet or something like that. The events the operator will perform is that they control the ferry boats, they sail across the traffic, they try to avoid collision with other ships. You may have the questions, well, will other ships respond to the ferries? In fact, the ferries have the lowest priority during the navigation, so they have to avoid other ships always, and other ships do not have to take the rights to avoid them. So in our system, even though other ships do not know we have a remote controlled ships here, but it's actually quite close to the fact. Throughout the exercise, we will record the success rates of collisions, avoidance, and groundings. We will calculate the time of the operations. We will measure the workload, and those are the criteria to evaluate our HMI design. Currently, we have already performed some preliminary tests. This is my colleague, Dr. Jinfen Zhang, with different types of EEG device to measure some brain waves during his operation of the control. We measured alpha, beta, all these kind of waves, and we can make some diagnosis with this kind of feedbacks. We quantify and compare the results of the mental working load, and we can also record some human errors. And we can tell something about the fatigue and the working pressure, etc., etc. And finally, we will try to validate HURID. And that's all for my presentation. And now I will give the floor to my colleague Barry to tell you something about just culture.
Thanks, Julian. So, okay, good morning, everybody. I'm going to talk about just culture. I'm Barry Cohen from Eurocontrol. So the three of us listed here are from aviation, and aviation is recognized as being the safest mode of transport. Part of the reason for that is because we learn from incidents and events. We have very few accidents, so we learn from near misses. And the way we can do that is because we have just culture. So what is just culture? It means if you make a mistake, whether it leads to not much or actually leads to a ship collision, unless there was gross negligence or reckless behavior, you will not be prosecuted. And so in aviation, pilots and controllers and other aviation professionals feel they can report events and incidents and say honestly what happened, because they know they're safe. They know that we want to learn rather than blame and put people in prison. So this is the way it works in aviation. And we were tasked by SAFEMODE and actually by the European Commission to answer this question. Would the maritime industry benefit from just culture? So this is another way of looking at it. I mean, it didn't happen overnight. In aviation, it took us some time to get it right. We had safety culture. We wanted learning culture. That's the final destination. That's what you want. You're learning from events so you can avoid accidents. For that, you need a reporting culture. And then for that, in aviation, we rely on just culture. But it's not necessarily an easy thing to achieve. Hence, I put it on this map, the other side of Tierra del Fuego. So it's tricky waters. To help us understand the maritime context, because we're not mariners, we've been interviewing a number of people, national investigators, and usually ship's masters or captains, and a few other people from the seafarer side. And we've talked to people from different segments in maritime and from a range of countries around the world. And we've done some very in-depth interviewing, and we're not quite finished, so there's still some thoughts to come in. So I'm going to talk about briefly just what they said about investigation, reporting, just culture, and learning. So here's some examples of what people have said. For example, I'm just going to move something out of the way. So the investigator creates a narrative, then the judiciary creates a different one, sometimes conflictual with the investigation. So there is this judiciary sense that justice must be served. So this can create a kind of tension about what really happened and can blur the real causes that we're trying to understand, in particular with SAFEMODE. Another one there for management safety is really a technical concern. They don't think they are part of the accident chain. So this is quite different from aviation, where managers, senior managers in aviation organizations understand that they set the staffing, the pay, the training, the equipment, etc. They know that if they get that wrong, then the people at the sharp end will suffer mistakes. So they know they are part of the accident chain, if you like, even if they're at the blunt end. So they actually understand that in aviation. And in maritime, it seems this understanding is not there. On a positive side, people pointed out the seafarers are really good at looking after each other, and they will do whatever it takes to save the day. And most of the time, they really do that. They look after things and go above and beyond. And there was a comment from another number of investigators about the COVID situation. For example, it says there some chartering bodies have opted for revised contracts with no crew change, as there is too much time impact. This has meant that some seafarers have been unable to go offshore for over a year. On the seafarer side, again, these are just examples. We have hundreds of comments. Reporting is what seafarers try to avoid at all costs. So this is quite a shock to us because it's completely different from aviation. And it is always blame the ship. That is the first reflex of some companies. I should say it wasn't all bad news. We did get some good news, but generally it was erring towards not a just culture picture. Another one there is a lack of empathy and trust from onshore personnel, even when they have offshore experience. And then a positive one, the master's leadership attitude and the standards he or she sets on a ship will improve safety. So we heard about micro just cultures on certain ships, even if the company didn't have a just culture process or atmosphere. So the master's leadership can be quite key on a ship. And another one, violations of rest hours and fake reporting are well known. So companies don't want to hear about it. This means if there's an accident, the rest hour, they can be falsified. So if you're having things like that, false records, then there is no way you can learn to be safer because you're operating on false information. We asked this question and we thought the answer would be 100% yes. And in fact, it was 50% possibly not. These were some of the things we heard. I should say that in aviation, it is the law. It took about 10 years to make it the law, but it is the law. So every aviation organization needs a just culture policy, processes, and they must try and protect the pilots, the controllers, other people. But this is what the seafarers and investigators said. If we could eliminate criminal and civil case proceedings, it would really help. Stop criminalizing seafarers. We heard this through 4 or 5 interviews. Sometimes they're used as scapegoats. So in aviation, in air traffic, I can count the number of criminal proceedings in the past 20 years on one hand. There's less than 5. Maritime may not be ready for it yet. We heard this from quite a few people, that some blue chip companies would be very open, but 90% of the world of shipping is operating under, and I know some people don't like this phrase, but it's what people said, flags of convenience owned by owners of convenience, using crewing agents, etc. So the business model in a way is not a good environment for just culture. People said you need to send a message, we're not blaming you, but we need to learn. Most human resources departments have no marine background. This is quite interesting to us. And they're defensive as they could end up in industrial tribunals trying to defend the company. So that's their world. So maybe something needs to be done about that. And this is one I want to finish on. It's just one more slide after this. The term just culture is maybe not what is important. We found excellent examples of learning culture in some of the companies we talked to. And so maybe it's better to talk about learning culture. So just to come back to this image, so I think there are 2 options. Maritime can try and do just culture, or maybe it can go direct for learning culture and try to go that way. So the next steps for us, we plan to develop a white paper. Now we may do that as a SAFEMODE white paper on its own, or we may do it together with the Maritime Coast Guard Agency in the UK and maybe a few other partners. So that it has both perspectives, maritime and aviation. We're going to allow plenty of time for review and then release it towards the end of this year. So thank you for attention, and I'll stop there.
Great. Well, thank you very much indeed, everyone. That was really interesting presentations there. We're run slightly over time, so we'll get straight into the questions if that's okay. first of all, Simone, if I could come to you, there's a couple of questions which I think you're probably best placed to answer. The first one is SAFEMODE just looking at the civilian aspects of marine and aviation, or is it incorporating military side of things as well?
Just civilian. I mean, we don't have, we will be looking into some of the military standards as part of the human factors toolkit, but just to have a look at the state of the art and choose the best in class methods, and to see what is the industrial practice. But the organizations are all civil oriented.
Okay, that's great. Thank you. And we had a question as well about when the study results will be available for people to use and that sort of thing. With Simone, is that something you'd be able to answer?
Yeah, there are already some results available, mostly at the high level of dissemination newsletters and news. We are waiting for the Commission to accept or reject our deliverables. After that happens, we will make a lot of our deliverables public. So we are past the midterm of the project. So we do have a number of reports ready for publication and public available. So if you are interested in staying updated, go to our website, subscribe to our newsletter, and you will get the news when the deliverables are online.
Fantastic. Thank you very much indeed. Throwing questions open to all the presenters. One of the questions that people are keen to know a bit more about was whether you found sort of similarities between aviation and maritime. What are the most the most sort of principal methods, sort of lessons that can be learned from that? We'd obviously, Barry's is a really good example of that, but I don't know who would like to sort of answer that general question.
I think that I'll start with this. Our working with aviation is not with this project, but it started 7 years ago with another project that called Seahorse. We looked at the number of similarities and the differences in the area. So we identified some of the the similarities, and both of them has a very good regulatory framework. The similarities are there. Where we found the difference is the implementation of the regulations. That's where the major differences are occurring. That's where Barry gave a very good indications of the difference in the fake reporting of the work and rest hours. And this came up in a number of times. And the aviation, if you fake a report, you face a prison sentence. But when we raised this type of discussions in the the large workshops that were more than 30 HSQ managers joined, and Maritime response was, but everybody is doing it. So we have in the implementation there's a major issues in terms of the frameworks and etc. It's a very similar. In some cases, I found this that maybe even better. When it comes to the we call what is imagined and what is happening in reality, as is a major difference where we found major gaps. We found so much of a workarounds, in Maritime, and it's a very open. Some of them are very valid reasons that, because the design is very poor and our procedures are very poorly written. Someone is practically trying to eliminate this, by doing a workaround to make it better, safer. But if this is not standardized and you do it without the ISM framework, then it is not becoming industry practice. That's where I think the aviation made sure that reporting culture, if there's deficiencies, etc., create a major boost for them to make it ISM successful for them, so that if there's a deficiency, report it. If there's a design deficiency, report it, and is there an alternative? They adapt it as a part of their procedures. But Maritime mainly, it is not really updated. but reported that people are doing their own, it becomes a practice, but without official documentation. So these are deficiencies that we have seen, but it's I think the good framework is there, but I think in order to apply it, we need the safety culture, just culture, hand by hand, will accelerate the coming to the similar level to the aviation.
It's interesting you say that, Osman. I mean, certainly my background's so from aviation and defence, and I'm always sort of interested to see in maritime that we do have structures and frameworks, but they're not populated in some areas. Do you think that SAFEMODE supports so safety improvement by demonstrating that there are ways to add to that framework, add to that structure?
Is definitely my personal, I'm sure my colleagues will say, there is a definitely, and I think there's a way to do it, but the way that we are trying to address is that we are engaging with the key stakeholders, constantly to make sure that what is being developed by SAFEMODE is applicable. We don't want to do academic exercise, but we want this to be used by industry, regulatory bodies, and finally the IMO. That's why we are engaged from day one with the EMSA, national authorities, that they are constantly providing feedback, find the gaps that what we are developing and providing feedback. And also the industry, especially shipping companies, if they are, they're creating this incident reporting, if they don't have a proper taxonomy, if you look at, I look at thousands of near misses and etc. From that, I cannot learn because information is not there if we don't follow the standards, etc. But we need to make sure that people understand that it can be done in this way. But people are generally scared of, if I report like this, it might be harm to my company, it might harm my, myself, etc. I think the just culture is also safety culture in my view. Is a way forward to accelerate it. I mean, I gave you one example. When we did safety climates, the survey with one company, big company, they came back. I asked, are you applying just culture? Oh yes, we do. But if there's an accident, someone has to pay the price. That was the middle management's view, the understanding. We need to change that attitude. I think we heavily, we really need the good middle management people that understand the operations, but they have the authority. Otherwise it creates a big top commitments and the bottom realities. There's a big gap that cannot be connected. This is my opinion at the moment, but based on our experience over the last 11, 12 years that we work with aviation. Thank you.
No, thank you, Osman. And I've certainly seen cases like that as well. We're slightly over time, so I'm just going to ask one last question, if that's okay. Barry, this is one for you. We've got a question about maritime culture, safety culture, and that maritime may not be ready for just culture. What do you think the first steps are for the maritime industry to get just culture implemented?
Yeah, thanks. It's a really good question. It's one we're pondering. So we've been having discussions with the MCA and other companies, shipping companies, etc. There's a lot of confusion over what just culture is and what it isn't. So I think the first thing is to get a good understanding of what just culture is and how it works, both for the seafarers and for the management in companies. It's like a handshake, if you like, between those two parties. They both have to know what they're signing up to. So we're going to try and work on that. We don't want to have a very clumsy, formal, long, 10-line definition of just culture, but something which speaks to both seafarers and managers and say, okay, this is what we mean. This is what just culture is. And maybe then a manifesto that organizations could sign up to and say, yes, we agree with this in principle. That to me is the first step.
Fantastic. That's great. Thank you very much indeed. Well, that's all we have time for, I'm afraid, in this particular webinar. Thanks again very much to all our presenters. Really appreciate your time and your input. It's incredibly important research to do.
Thanks, Katrina. Thanks, Will.
Thank you.